Hi, in this video we're going to look at plotting some straight line graphs. This could appear on both the higher and foundation exams as it's a grade C topic, but the second half of the video is going to predominantly explore the ones that are going to be on the higher paper as opposed to the foundation. I'll let you know when that happens. One of the things that we're actually looking at doing in this video then, we're going to have a look at plotting straight line graphs in the form of y equals mx plus c. So it's going to be something like y equals and then a number in front of your x plus another number. There might not be another a value at the end here, but there's more than likely going to be, and this is definitely one that could appear on both foundation and higher. And in order to do that, I'm going to encourage you to form a table of values. And if you're not sure what that means at this point, then we'll have a look at that. And then further on, I'm going to show you some more sorts of straight lines, but they're not in the normal form that you'd expect of y equals mx plus c. They're going to be something like this. Ax plus by equals n. And again, this just means a number in front of x plus some number in front of y equals another number. And this is much more of a higher topic, but I'll show you how to do this. And if you're a foundation student, then when we get to those ones, don't have a go at those questions, just concentrate on these y equals mx plus c ones. In this first example, we're going to have a look at plotting the graph of y equals 2x plus 5. Now, you should look at this and expect it to be a straight line. The reason it's a straight line is that your x is only to the power of 1. There's only an x here, there's no power above it. If it were x squared, that's when we'd start expecting it to be this nice smiley face or a grumpy face kind of graph. If it's an x cubed, it's going to look a little bit more wiggly. You're not going to experience anything else at this stage. You might see a reciprocal graph as well, but let's not worry about those right now. This one is a straight line graph because it's just a x to a single power, so just an x on its own without any powers to it. Okay, how are we going to do this then? Well, I've got some graph paper, but I'm not entirely sure where to put my points. Now, if you've watched the other video on finding an equation from a graph, you might be confident enough to think, well, I know what some of this information tells us. I know that this plus 5 here, it means it's going to cross the y-axis at 5. Okay, it's going to cross over here. You might be happy to think, well, this 2 means a gradient of 2. So every 1 along, it's going to go 2 up. 1 along, 2 up, and so on. And if that's the case, you can just go straight ahead and do that. Okay, you can plot a few points that go 1 along and 2 up, all the way along, until you get yourself a nice straight line, join it up, job done. However, not everybody's going to be happy to do that. And if you're not, then what I'm going to suggest that we do is that we use something called a table of values, and that's what I'm going to do now. Now, a table of values just means we pick some values for x. And these can be anything at all. I would recommend that you would probably start off with something simple like 0, 1, and 2. Now, I've made these numbers up. They're not special numbers from anywhere. All it really means is when x is 0, that means the x coordinate, so along my x-axis. So along my x-axis here, I'm going to see what happens when x is 0. Okay, so let's see. If I substitute 0 in for the x that I've got in my equation, so here, if that x was 0, let's see what the y value would be at the other end. So this would mean 2 times nothing, because x I'm saying is 0, 2 times nothing, well that's nothing, plus 5 gives me an answer of 5. So when x is 0, y is 5. What happens when x is 1? Well, 2 times 1 is 2, plus 5 is 7. So when x is 1, y is 7. And for the next one, when x is 2, so again we're substituting 2 in here, 2 times 2 is 4, plus 5, we get 9. Now this actually gives us 3 coordinates. Remember that our coordinates are in the form x, comma, y. We've actually got 3 coordinates here. We've got this coordinate, 0, 5. We've got another coordinate, 1, 7. And a third coordinate, 2, 9. And again, if at this stage you feel more confident writing those down, just so that you don't forget, we've got 0, 5, 1, 7, and 2, 9. These are the three coordinates we're going to plot on our graph. So let's do that. 0, 5 is here, 1, 7 is here, and 2, 9 is here. Now, the keen-eyed among you will realise that these are the same 3 points that I put on before. More by luck than anything else, but it turns out that they were. Now, with a ruler, you need to join up these points all the way along your graph. Now, my software is not brilliant for drawing straight lines, I'll be honest, but I'll give it a go, and it's going to look something like this. You can see that my line is quite wiggly. That's only because of the software. You must use a ruler, and you must go through all the points and keep going. Don't just join the 3 points up that you've drawn. Keep going all the way down to the bottom and the top of the axes that you're given. Okay, what I would finally do, just for completeness, is label this y equals 2x plus 5, unless this is the only thing you've been asked to do. If you draw a number of graphs on the same set of axes, I'd always label them just so that you can see. Otherwise, we've completed this one, and like I say, you will draw it with a straight line and a ruler. I apologise that mine can't do that. Right, let's have a look at example 2. If at this point you're ready to have a go by this by yourself, feel free to. Otherwise, I'm going to draw out a table of values again. I'm going to have my x and y. I'm going to pick 3 numbers again at random, but I'm going to use easy numbers. I'm going to pick 0, 1 and 2 again. You don't have to use these, it really doesn't matter, but I find it easier to use simple numbers to start with. So let's see what happens when x is 0. That means 3 times nothing is 0. Take away 6, I've got minus 6. When x is 1, 3 times 1 is 3. 3 take 6 is minus 3. And when x is 2, 3 times 2 is 6. Take away 6, I've got 0. Okay. And I've got 3 coordinates. I've got the coordinate coming from this pair here, which is going to give me 0, 6. I've got another coordinate 1, minus 3, and a third coordinate 2, 0. And these are the ones that I'm going to plot now over here on my graph. So 0, 6 is up here. Then, sorry, 0 minus 6, I've made a mistake here. I've just changed that. So 0 minus 6 is down here. 1 minus 3 is here. And 2, 0 is here. And again, join these up with a straight line. I'll have a go again with my iPad and ruler, which is not the best way to do it, but it's the only way I've got currently. Here we go, something like that. Again, you have a go doing yours slightly better than mine. Okay, so what we need to do now is have a look at the third and fourth examples. Now, these ones are only for higher GCSE pupils, so if you've been thinking about doing this for foundation purposes, then you can skip ahead a little bit until you get to the questions that you can have a go at by yourself. Otherwise, if you're higher, carry on watching. Have a look at this example. Now, this looks different. This isn't in the form y equals mx plus c. You've got an x and a y, and it equals 4. Now, actually, this is quite straightforward. What I'm going to do is show you something called the cover over method. And all it really means is covering over the x and seeing what y is, and covering over the y to see what x is. But you might not really realise currently what that means. Let me see if I can explain. So what I'm saying is, if x is 0, so if I cover over the x, it's saying if x is 0, what would y be? And obviously here we can see it's 4. So when x is 0, so that's none along the corridor, we have 4 up here. Okay, so when x is 0, y is 4. Let's cover over y. This is saying when y is 0. So what would x be then? Well, when y is 0, x is 4. So when y is 0, x is 4. That's here. And again, all you need to do now is join these up with a straight line. Something like this. Okay, again, my line's really wiggly. It's just that I can't use a rule at all with this software, so I apologise for that. But you can see the idea. You can see what's going on. Let's have a look at a final example like this before you can have a go yourself. example, we've got 3x plus 2y equals 12. Okay, but we're going to do the same thing. We're going to use the cover over method. So with the cover over method, we need to cover over our 3x. So let's cover over 3x. So this is again saying when x is 0, what's y got to be? Well, 2y is 12, so that means that y would have to be 6. So when x is 0, y will be 6. And finally, when y is 0, 3 times something is 12, so the something's got to be 4. When y is 0, x is 4. So again, let's just mark that on here. And again, we join that up with a straight line. So it's going to come through something like this. Okay, again, you're going to use a ruler. I'm not going to keep labouring the point. Right, this is your chance to have a go now. I've got 4 different ones for you to have a go at. Again, as I said before, if you're a foundation student, then you definitely need to be able to do the first 2 here. If you're a higher student, then you need to be able to do the first ones and also these second ones as well. Okay, so pause the video, have a go at plotting them, check the next few slides and be able to see if you got them right. Okay, so here are the solutions then to the following ones. Y equals 3x minus 1. You can see here from that we cross at minus 1. This is a key point, and it has a gradient of 3. That means 1 along and 3 up. The second one, y equals 2x plus 1. It means that it crosses the y-axis at positive 1, and it has a gradient of 2. That means 1 along and 2 up. For these final ones, x plus y equals 6. You should have these solutions here at x equals 6 and y equals 6. And the last one, 2x plus 3y equals 18. Along your y-axis, you should be intersecting at 6. And along your x-axis at 9, and a nice straight line in between. Now, with all the videos that I've made so far, we've been making revision card notes at the end. Key things for you to think about here. If we are doing y equals mx+, unless you're really confident with gradient and y-intercept, draw out a table of values. Okay, I can't stress that strongly enough, and actually when we're doing most graphs I'd be recommending doing a table of values, especially if we're doing ones with x squared or anything a little bit more complicated in. If it's in the form where you've got an x plus a y on the left hand side and then a number on the right, I want you to use this cover over method as you've just seen in the last 2 examples to be able to have a go at that. One more final thing while we're talking about straight line graphs, I'm hoping again that you've realised that graphs that go in this direction have a positive gradient and graphs that go in the opposite direction have a negative gradient. Even if it's in this form, your algebra skills might be good enough to rearrange it into this form here, and you will see that the m part is the gradient and that would be negative when it looks like one of these ones on this side here. If you're not sure of that, I've made another video all about y equals mx+c and the gradient. Check that one out. Good luck with your exams. I hope that everything goes okay. Keep watching the videos, leave any messages, or if you want me to make anything in particular, leave me a comment and I'll endeavour to do those as soon as possible. Okay, thanks very much. Bye.